right, homework out, textbooks open to page 174. Let's take a look at numbers 7 through 16 that you did for homework last night. Solving systems, I told you you could choose your method. The book had their recommendation, substitution or elimination, but you pick what works best for you. Number 7, what was your answer, Maddie? -5. -1. Okay, that's what I thought I heard, and then I second guessed myself. -5, -1 is right. Number 8, Noah.
3, -2.
3, -2 is correct. Number 9, Brecken.
-2 and 2 11.
Ooh, Maddie. Oh my.
I got 0, so I put no solution.
Should be -2 too. Let's take a look at number 9 real quick. We've got 5x positive 6y is equal to 2, and x plus y equals 0. Did you use substitution or elimination, Brecken? Substitution. All right, so you had to get a letter by itself then. And how did you rewrite this bottom equation?
X equals y plus 0.
Ah, careful. If you move the y over, it becomes a... So x equals -y. And you could say plus 0. Plus 0 is literally worthless. So we'll just say x equals -y. And that's where we got the 11ths from. Because the -y should have gone right here where it says x. So 5 times -y should have given us -5y. Plus 6y equals 2, we combine like terms. Well, -5y positive 6y just gives us 1y, or y equals 2. There's my answer. Plug that in here, x equals -y, that's x equals -2, and that should have been our answer there. Maddie, you also had 2 11s. Did you use substitution or addition? All right, same thing, you forgot to make it a negative?
I had a negative, but then when I put it back for like the 5, I had a positive y.
So you wrote x equaled -y, but when you plugged it in, you didn't treat it like a -y. Okay, question. Noah, you good on -2? No. Well, did you do substitution or addition?
I did the same thing that Brecken did.
Okay, question. All right. Let's pick it up with number 10 for redemption, Brecken.
1 0.
Maddie? Should have been -5 3. Brecken, substitution or addition? So you rearranged the top equation to say what?
X equals 1 -2.
Okay, good. So you did change the sign correctly. We're going to take the 1 minus 2y, plug that right in here where it says x, and distribute to get.
I put positive 2y on the thing.
Oh, so again, when it moves over, you've got to change that sign. So it should it have been?
3 times 1 2y plus 2y. 3 -6y plus 4y plus -3. -2y.
And then when you plug that in, that's where we'll get the x equals -5. So there's our -5 3 answer. Third tries the charm, Brecken, number 11.
Got -4 4.
Close, Noah?
4.
4. I assume you multiplied a 2 through the bottom first, correct, Brecken? And so that gave you a -3x positive 2y equals -4. When you put the 2 through the bottom, -2x -2y equals -16. You cancel the positive and -2y's, I believe, to get -5x equals -20. And that's where you got the x equals +4, correct?
I put positive 5 at the bottom and
Oh,
negative.
so your answer was -4.
-4 4.
-4 4. But you did still multiply the 2. So right here, you just lost the negative. Instead of add and keep the sign, you just added and lost the sign. And so you got a -4. So we actually had 2 mistakes then. First mistake was it should have been a +4. Then when you plugged your -4 back into the... Which equation did you plug the -4 back into? top one. So when you plug your negative 4 in here, which should have been a positive 4, I think you made another mistake here in that when you did 3 times 4, it should have been a positive 12, negative times negative, which would have moved over as a negative 12. But you didn't treat it like that, you still treated it like a positive 12, and hence you ended up with a correct y value of 4. But again, since it should have been a positive 4, it should have been a negative 12, which should have, yes, moved over as a positive 12 to get you 2y equals 8, y equals 4. So you made a couple of mistakes there. Lost a negative, and then when you plugged it back in, forgot to change the sign as you changed the side. Fourth tries the charm, bracket number 12.
Yeah, this one's not right at all. I know it's not. Because I got a 0 and then a big fraction.
Well, you're right. Maddie? 0.4 is correct. Brecken, you use elimination or substitution? You said elimination? Which variable did you get rid of, x or y? X. So you multiplied the bottom by 7, which gave you what equation when you distributed?
Negative 7x negative 43 y equals 168.
Well, it should have been negative 7x positive 42y equals 168. So that might have been part of the problem here. The x's will cancel, and when they do, you should have added 4 and 42 to get a 46y, added the 16 and 168 to get 184, and that would have given you y equals 4. So that doesn't make sense that you would have multiplied 7 because you had the correct x value. Oh, you got a crazy fraction right here. And so instead of plugging it back in, you said restart, now let's get rid of the y, top by 3, bottom by 2. And that's how you were still able to get the correct x value of 0, as opposed to trying to plug the 4 back in. Okay, that makes sense. So yeah, just be careful there on solving through, because you're solving for x was perfect, solving for y, a little mistake there, question on that. All right, fifth tries the charm, as they say. I'm not sure who they is, but number 13, Brecken.
I don't think we can read either. Okay, so
What'd you get?
a fraction, okay.
Just read it.
Negative 10 over 4 and negative 1.
Noah, what'd you get?
Negative 2, 0.
Oh, Maddie, what'd you get? 2, 3 should have been her answer. I'm going to pick on Noah this time, Brecken, since he missed it also. We got a 3x negative 4y equals negative 6. We got a 7x negative 2y equals 8. Noah, I assume you did the elimination method, because substitution would just be a whole lot of work, and we hate work because we're lazy. So you chose to multiply bottom by 2, which initially, when you just multiplied the 2, gave you what new bottom equation?
14x negative 4y equals 16.
But the 4y's wouldn't cancel. You'd have to change the signs now across the
Bottom. Or top.
I got little numbers up top. I would have changed them up here, just as a strategy. So that might be part of your problem. So you would have gotten here 11x. Now, if you change across the bottom, it would have been negative 11x. These would have canceled, and here should get 22, but in your case would have gotten negative 22. And that's okay. If they were both negative, of course, the negatives would cancel. What I think the mistake happened, perhaps with you, is you only got one of these signs correct. And that's what happened. So should have gotten x is equal to positive 2. You had negative 2, which is why when you plugged it in, you wind up with a 0 instead of plugging it in to get y equals 3. Again, when you plug that correct 2 back in, let's just go right here, back to what we originally had. 3 times 2 would have been 6. Again, if you had negative 6, you would have brought it as positive 6 and canceled. Should have been a positive 6. It gives you a negative 6, giving you negative 12 equals the negative 4y, and that's where Maddie got the y equals 3. All right, let's see. Sixth tries the charm, as somebody has said once. I think it was me. Number 14, Brecken.
Okay, so I think I got 13 and 14 mixed up. But I got 2, 0 on 14. And it's the same exact equation as that one right there. So I think I put it.
No, what'd you get for 14?
1 and 1.
Maddie, what'd you get for 14? Negative 4, 1 is correct. Brecken, you're back on the hook. 2x positive 5y equals negative 3. 4x positive 3y equals negative 13. Brecken, what should we have done
Multiplying the top by 2.
to get
4x positive 3y equals negative 6.
all right, then what should we have did?
Change the sum of the bottom. Then cancel the 4 and get 7y equal 7. Divided by 7. Get y equal 1.
You didn't do that though, did you? That's what you should have did, and you know you should have did it because you just told me you should have did it, but you didn't do that.
Yeah.
Do that. Then we need to take the y, what do we need to do with it, Brecken?
Plug it in for the equation, the 2x one.
The one that we kind of scribbled out right here, okay? We'll plug it in right here for the y. So that says positive 5 times 1, which is,
Positive 5.
but we move that over,
Negative 5.
yeah, and that gives us,
Negative 8.
so 2x equals negative 8.
Divided by the 2 to get x equals negative 4.
Thou knowest what thou oughtest to do. Thou didst not do it, thou mustest do thusly, forsooth. Verily. All right, I lose track of which try we're on. Is this 7th try now? 7th try is the charm, Brecken, number 15.
It's not right. I don't know what I did, but it's not right. There's like huge fractions, and I know it's not right.
Noah, you need a 3rd try. What's number 15?
2 and 4.
Oh, Maddie!
4 over 3 and negative 4.
Nobody got it. All right, Maddie, I'm picking on you this time because you have a rare miss. The guys are like, ha, and they're like, oh, rare miss. Oh, okay, never mind. We can't laugh. We have frequent misses. All right. All right, Maddie. Half of your answer is correct. So just talk me through. What did you do first?
I multiplied the top by 2 and then divided by 3.
All right, good choice. And that gave you what new system?
6x plus 4y equals 2.
Good. And then at the bottom,
Negative 6y plus 15y equals negative 78.
all right, I think you may have misspoken just a moment ago. Did you mean to say negative 6x positive 15y equals negative 78?
Yes.
Okay, and so your 6x is canceled. That gave you,
19y. Negative 76.
and I believe you got negative 4 there, correct? All right, then you needed, this is where we ran into problems, that we should have taken our negative 4 and,
Plug it back in for the y.
right here, to get,
Negative 20. No, negative 20.
negative 20, and move that over as a, to get
Negative 6.
is equal to,
Negative 2x.
so x should have been, and that should have been our answer, 3, negative 4. Gentlemen, questions? It's our last chance. We gotta do this. We gotta get one right. Number 16, Brecken. I laugh only because crying on camera is just sad, and I'm not gonna do it. So,
I'm scared to answer.
what'd you get?
I got 34.
Oh, so close. I might cry. Noah,
9-3.
you're a disgrace.
25 negative 4. 25 negative 4.
Brecken was the closest. Brecken, I'm gonna have you help me. What did you multiply equations by?
Multiply them by the 2 and 3 posts.
All right, so what was your top equation when you multiplied by 2?
Negative 6x. Positive 8y equals 50. Negative 50.
Is that actually what you had?
And I had negative 50.
Okay. What'd you get when you multiplied the 3 by the bottom?
6x positive 21y equals negative 66.
Is that what you had? Okay. All right, Brecken, now what we gotta do?
Cancel out this 6.
As we add the equations, right? What do you get when you add 8y and 21y? Because the signs are the same, we add and keep the sign. What do we get? We add negative 50 and negative 66. That is correct. And you divided both sides by 29, and you got,
where did I put it? 4.
but we should have gotten, somehow 2 wrongs made a right for you on the next thing, because you took what was a 4, should have been a negative 4, but you took your 4 and plugged it in for the
original one.
right, which one, top or bottom?
The bottom.
The bottom. So you took 2x plus 7 times, and you said 4 should have been negative 4 equals negative 22. And you said that 7 times 4 was,
28.
but when you moved your 28 over, you didn't change it to a negative 28, which is how you got the correct x value. It should have been a negative 4, so it should have been a negative 28, which should have moved over as a positive 28. But if this were positive, it should have moved as a negative. You messed that up a second time now. So that gave you 2x equals
negative 22 or something. What did I put? 2x equals
6.
6. Yeah.
And you got x equals 3, which is correct. So again, a couple of mistakes here, but 3 negative 4 should have been our answer. No many questions. Here's the thing. I feel like we know what we're doing. I feel like we make careless mistakes because we're not paying attention on the homework because maybe we don't care about the homework. Maddie excluded. She only missed a few. But I feel like we're like, it's just homework. Kind of like some athletes. Like, it's just practice. Does it really matter? Was it Marvin Harrison, one of the great receivers in NFL history, once said, I think he has the record for the most receptions in a single NFL season, 143 catches in a single season. And Peyton Manning's favorite target. You know, my age is being revealed here. But he said, I get paid to practice. The games are just for fun. Okay? The games are the games are the fun part. That's why he plays the sport. He gets paid to make him go to practice. Practice is important. That's what homework is for you. We don't want the Allen Iverson mentality. Practice? You're talking about practice? How silly is that? There's a reason his career was short. One of the most talented basketball players ever. Career shortened because he just couldn't make it. He wouldn't practice. Didn't care about practice. This is practice. Put effort into it. You know what to do. Do it right. Give you one more problem before you take this quiz. Good luck. 3x fourths minus 5y halves equals 21. 2x thirds plus 2y fifths equals 44 fifteenths. Alright, for sake of time, check your work. Let's see how we did. Should have multiplied everything through by 4 in the top. Should have multiplied everything through by 15 in the bottom. Did we do that? Multiply by 4, multiply by 15? Right here, at the very beginning, to clear the fractions out. Okay. Then after that, we get 3x minus 10y equals 84, 10x plus 6y equals 44. Did we get this system once the fractions were gone? Did we then perhaps, it's kind of a toss-up, either get rid of the x's by getting 30s, 10 and 3, or multiply by 3 and 5 to get positive negative 30s. I went with the y. Did we also go y or did we go x? You went x?
I went X, but I took a 2 out of everything.
Ah, that's an interesting approach there, something we've mentioned once before. So you said, let's make this a 5x positive 3y equals 22, and you went for the y or the x? You went for the x, so you did 5 and 3 for your numbers then. Still would have worked, okay? Should have, and if you went with the x, you would have gotten y equals negative 6. Did not get there yet. Let's see what we should have done real quick. Should have gotten 15x minus 50y equals 420, and 15x positive 9y equals 66. Then you would have had to change the signs presumably across maybe the bottom here, and got negative 59y equals negative 480, no, we're subtracting here, equals 354, negative 354, positive 354. And that's where you would have gotten the y equals negative 6, okay? So were you on the right track at least, okay? Noah, questions? Were you good on the right track? Or did you find a mistake?
I tried to get 30.
With the x's. So you went 5, 10 and 3. So you would have had basically double what he had here. Yeah, you would have had 30x negative 100y equals 840, and negative 30x negative 18y negative 132. And so you would have had negative 108y equals 708. And would have had to divide the 108 into the 708, or 118, excuse me, into the 708 to get negative 6, which is a lot of division. All right, questions on this? We're going to have to actually save the quiz for the next lesson. We do not have time, so we will take a quiz tomorrow over this, give you a chance to figure out your issues. Turn to page 168. We're going to kind of change gears here just a little bit. Page 168. And after the quiz tomorrow, we're going to delve into solving word problems using systems of equations. And once you've got solving systems down, because you're careful and pay attention to details, then solving systems of equations can make word problems really easy. Because usually, how many unknowns are in our word problems class? Most of the time, 2. We've done some with just 1, which is just algebraic representation. We've done some word problems with 3 or 4, but most of them, let's be honest, it's 2 unknowns, right? Well, so far we would pick one to be x, and we'd figure out how to represent the other one. But no longer. If there's 2 unknowns, one's going to be x, one's going to be y. And that's going to really simplify our setup. Look at the example problem at the bottom of page 168. Go ahead and read the problem in bold for us if you would, Noah.
The sum of two numbers is 71 and their difference is 13. Found the numbers.
All right, the sum of 2 numbers is 71. Well, I don't know what my 2 numbers are, so we'll call our first number x, because I don't know it. And our second number we will simply call y, because I don't know it either. So when it says the sum of 2 numbers is 71, I could represent that x plus y equals 71. Super easy, right? And then it says their difference is 13. Maddie, how do you suppose we'd represent that their difference is 13? X minus y equals 13. And so instead of figuring out which one should be x and how to represent the other one, don't worry about it, it's x and y. Sum is 71, difference is 13. And as we solve, well, the y's are already set to, class, cancel as we add the equations together to get
2x
equals 84. Divide away the 2x must equal
42.
42. Well, there's your first number. Remember, they have a sum of 71. What number added to 42 would give us a 71? 29. And how do we check it? Take the other piece of information. The difference should be 13. Is there a difference of 13?
Yes.
And it checks out. Really easy to solve word problems using systems. Look at the next example, example 5.4b. Read that problem in bold for us, Maddie.
A number is one more than twice as large as another number. Twice the smaller number added to 3 times the larger is 59.
Again, there's how many unknowns, class?
2.
Now this time it describes one number as being larger, and it describes the other as being smaller. That's okay. I can still represent my two unknowns, class, as X and Y. And so when it says that a number is one more than twice as large as another number, we know that means a large number is going to be one more than twice as large as a small number. How would I show that one number is one more than twice as large as another, anyone? One number is one more than twice another number. One number is one more than twice another number. There we go. And then it says, the next sentence tells me that twice the smaller number, class,
2x.
twice the smaller number, 2y, added to 3 times the larger,
3x.
plus 3x, is 59.
Equals 59.
Probably want to solve this by the substitution method, right? Nothing's really lined up here. That's okay. Put it in right here, right? Get 2y plus 3 times the 2y plus 1 equals the 59. Let's go ahead and distribute to get, class.
6y plus 8
Equals the 59. Combine like terms.
8y.
Ditch the 3 as a negative to get,
56.
and divide away to get y equals
Plus
7. So x must be 15. So my big number is 15, my small number is 7. Let's see, it said twice the smaller, class, 14, added to 3 times the larger, 45. 14 added to 45, and it checks out. Does that make sense? So again, it saves you the trouble of worrying about how to represent the unknowns. If it's just, oh, there's 2 of them, x and y. And that's just what we'll do. Turn over again now to page 171. Turn over to page 171. We can use this in interest problems. Read this problem for us, Brecken.
An investor plans to invest a total of $10,000 into accounts with annual simple interest rates of 8% and 12%. If the combined annual interest is to be $1,080, how much should be invested at each rate?
Now, it's still an interest problem, so we still have the PRT equals I. We've got the 2 different rates, though, right? We have the 8% investment and the 12% investment. And the rates, of course, become 0.08 and 0.12, just like they would have earlier in the year. It mentions annual interest, so the time is still just 1 year. We sometimes would just say, forget the time column then, rather than wasting our time putting it in there. But the principle was always the question, how do we represent it? Well, there's 2 unknowns, so how do we represent the principal, class? X, Y. And we know that if we multiply P times R, it equals I. So P times R would be, and P times R would be, but we have to make 2 equations, right? The first number that they give us is the $10,000. What is that? That's the money he's going to invest, right? That's called principal. Money that gets borrowed or money that gets invested, loaned out, is principal. The principal is $10,000. What's the other number we haven't used? 1,080. And that sentence tells us that's the combined annual interest he's going to earn. 1,080. So he invests 10,000. Some of it's X, some of it's Y. So X plus Y would equal 10,000. He's going to earn this interest and it's going to be a total of 1,080. So this interest plus this interest equals that interest. And there's my system of equations. Make sense? It just simplifies the process a little bit. Now, to be fair, I really hate decimals, right? So we're going to move the decimal 2 times, which is going to make this become 8x. This is going to become 12y. And this, if I move the decimal 2 places, it means I need to add on 2 zeros, right? One more thing we need to do here. I don't want to solve with all these big numbers by the substitution method. So I'm going to multiply the top by either 8 or 12. 8x, 8y, 80,000, right? And then let's change the signs across the top. Negative, negative, negative. This gives me 4y. And we got to kind of think upside down here. It's a 108,000 minus 80,000. 28,000. Divide by 4, y must be $7,000. Remember, 10,000 total, 7,000 here. How much here? 3,000. And it just makes the process easier. Technically, we're doing a whole lot different than we would have done before, but we didn't have to do as much thought because we could use X and Y and set up a system. That's what we're going to be working on in the days ahead. I will give you one extra credit problem this evening, page 173, number 2. Page 173, number 2. We'll take a look at that tomorrow, because in solving the word problem, you will be working a system, but then we'll have that quiz tomorrow, and then after the quiz, we'll devote the remainder of the class time tomorrow to solving word problems using systems of equations. Have a wonderful rest of your day, and trust that tomorrow on the quiz you will work carefully and thoughtfully and not make careless, stupid mistakes. Have a great rest of your day.